So we've got a bit of vintage tech to look at today. This is the Selectest Super 50 multimeter. It is a voltmeter and ammeter in one. This meter comes from around the 1960s, I'm going to guess 1965. I can't find a date in here, so there's nothing on the outside. I can't see anything on the dial. I thought there might be a manufacturing date down here somewhere, but couldn't see one. Nothing around anywhere. There is a date on the top here. It says the 1st of November 1975, but it's probably a test date and there doesn't seem to be anything else. This one says 1977 just there, but I believe it was manufactured earlier than that, but I could be wrong. It could be well smack bang in the middle of the 70s, but I found reference to it in magazines from earlier than that. I just don't know when this particular one was made. Now, it's a beautiful thing, isn't it? It looks a little bit like one of those Avo or Avo meters from a long time ago, but a bit more up to date, I guess. So it's got this huge analog display here, which is amazing. So this is this display works on 0 to 50 microamps, full scale deflection. So that's what it would take all the way. And you can also reverse it. I don't know how to do that. So for negative voltages, it might be this rev dot here, and then maybe you twiddle it around. I don't know how that works. Couldn't find complete reference in the manual to that, which by the way I have. So I bought it? No, I got given it rather, about a year ago. And I've been searching for the manual for this for a long time. And then a dude at Richard from Richard's Radios, he's got a web page about this very meter with pictures on the inside. So I sort of know what to expect. We're going to take it apart, by the way. I sort of know what to expect. And then I dropped him an email and said, "Oh, I read you got the manual for this. Is there any chance I could get a copy?" And he said yes. And he emailed me the PDF, so I printed it out. And I sent him, as a thank you, one of the very last binary clock kits that I have left. I have a few still, so he's got one now. So I think there are only 2 left now. Anyway, we've got the manual for it, which is brilliant. It doesn't have disassembly instructions, but that's okay. And there's no date in here either. But it is from Salford Electrical Instruments Limited. But also on the back, I can see that it says the General Electric Company. So I don't know whether they're just sort of distributed in different markets under different companies. But we've got sort of the general specs, the ranges it can do, they're fairly standard. I mean, also on the top here, we've got 2.5 kilovolts DC and AC that it can read. So it can go up pretty high. But I won't be obviously testing it that high. But essentially, let's see if we can, I'm not going to tell you about how an analog meter works because I won't be good at explaining that. I don't know, I'm not an expert, but we can have a little look at it. And interestingly in here, I'm just going to skip through and not show you some of these bits, but in this manual, and I love it for it, it's only got the schematic in here. So we can actually look and try and identify some of these things if we can get inside it. I don't really know about the construction and I don't want to risk breaking it. So I'm not going to take any risks here. If I can take it apart cleanly, I will. If not, then we'll just have to sort of just talk a little bit about it, do some tests or whatever. But you can see here we've got our DC switch just there. We've got our AC switch just there. Those are our inputs just here, and down here we've got our moving coil magnet meter thing. Is it a galvanometer, something like that? I can't remember. Someone once told me and I'm trying to recall. I haven't done any research on how these work, mainly because I don't think I'd understand it anyway. We also, I would have thought we had a full bridge rectifier in here for the AC input, but perhaps not. So AC comes in here. There's a cutout switch. That's that red button down here. If that's popped down, it's on the cutout, and if it's pointing out, it is free. So you can see there, it's a plunger type switch. Yeah, I don't really know how it does the AC. That will be one of the mysteries that I can't answer. Anyhow, this is the Selectest Super 50. So we're gonna take some parts out. Now, because I've had this about a year, I have already taken the back off, but I haven't gone inside the unit. So let's turn it over and have a look. I'll screw these in first so that we're not placing it down at an odd angle or putting too much pressure on these. It also needs a little bit of calibration. You can see on the top the, shouldn't really drop it. It's not zeroed out. From parallax is a bit weird for you guys, I'm sure, but it doesn't look right to me. So on the back, interestingly, and you don't get this on on another meter. I've got one here so we can compare, but you've got how to use the device, which is pretty fantastic. So yeah, I'm really happy about that because it meant that I didn't really need the manual to use it, but I did wait to use it with the manual. So we've got DC volts, set it to DC and use the plus and minus terminals. Anyway, we don't need to know all of this stuff, basically. It's going to be fairly similar to using any other meter. But let's take the back off. This is where the battery compartment is, and I've been in here before, so I'm going to feign some surprise. Oh my God, look, there are batteries inside. Okay, I knew they were inside the whole time, but look at those, aren't they cool? So this one over here is a 15-volt battery, the BLR121, and then we've got this battery here, an ever-ready 1.5-volt SP2. Let's have a little closer look at these batteries, shall we? So we'll start looking at this one. So this is the 15-volt battery. It's a really interesting little cell. Made in Britain. I imagine it's not just one cell. I would have thought it was lots of them, but there we go, 15 volts. And we're going to test these batteries on that multimeter in a second. Then we've got this one. This is the ever-ready battery, 1.5 volt SP2. And the thing that really caught my eye, apart from it saying for longer life, is that it says ever-ready battery made in West Germany. Now, SP2 also is actually a D cell, so I don't know when they changed the naming conventions for that, but West Germany, this battery looks to be a bit 70s to me. It could be a bit later than that, but the design I Googled for ever-ready looks, lots of the references were to the 1970s. And West Germany, that ceased to exist in 1991. So I don't know when this battery was made, but yeah, the wall definitely fell in 91, I think. Definitely fell, I think. No, it did. So let's take the screws out of here and get in the back. You can see where the batteries sort of slot in. There's a bit of corrosion down here. I've scraped a bit of that away, but that's where the batteries have been for, well, I left them in and I've had them for a long time, so I don't really know. I guess it's been like that since whenever those batteries were purchased and put in. It is the 5th of November today, so if you hear lots of banging and fireworks noise, then that is the reason. Oh, before we do this, let's measure those batteries, shall we? So let's have a look at the 15-volt battery and see what kind of current kind of voltage rather it is holding. So we've got 13.3 and falling as we're drawing a tiny amount of current to read the voltage. So I'm going to guess that it's not really going to hold the charge for very long. It's basically a duffer, but I'm going to keep it because it looks cool. And then we've got this one, the ever-ready SP2 made in West Germany. So that is holding 1.353, and again it is falling, but only very slightly, so it's not falling significantly there. So actually it's probably still usable for a bit, but we're not going to use it. I'm going to replace those batteries. I have one of these, which is a D cell rechargeable. We can use that, and then I have a replacement for this somewhere. I'll find it in a minute. Anyway, we're going to get inside this. Now, let's see, can we just lift this out? Let's take those screws out. Oops. I've lost one on the floor, but I'll find it in a bit. No, maybe I need to take the range switches out. Do they just pull out? Yep, they do. Let's try that. Oh, that is promising. No, there's something going on up here. Let's have a little look. I'm gonna have to take the 0 ohms knob out. Bear with me. Right, let's see if that works. Well, there we go. Right, we are out. Let's pop that over there. Whoops-a-daisy. Got a rogue spring there. I'll look after that. These foam sections here have seen better days. I'm just going to refocus the camera. There's our needle, which seems to be... Oh, it's moving because I'm breathing. I was wondering why it was moving on its own. So it looks like we've got a couple of screws here that we can take out to remove this plate. I don't know if I want to take out the whole assembly for the needle, but we'll take this plate off and have a little look. But you can see we've got our large range switches here. And in fact, let's tilt this up so you can have a little look. Let's see if we can zoom in a touch. So yeah, we've got our large range switches here, and here's our cutout. I said it was a plunger. That's what you get. I'm not quite sure what the release mechanism is there. So when you have a fault, should that not pop out? But it should stay in, but I don't know why it popped out. So we'll leave it for now. But yeah, you've got the range switches there. I'm not quite sure what that contact is for. What would that be? Let's have a little look. Whoops. Oh, well, I've lost that. Okay, that's interesting. So on the back here, we've got this little turning dial with a pole in it. That seems to align with this rod here. You can't see that. So that little nub in there seems to align with this one here. That looks like it's the 0. And then this bit goes to, I see. That one goes to the reverse. So when you push that in, it pushes this down and changes the polarity, it looks like. Interesting. So we've got a bunch of other stuff going on in here. You can see some of the components. Well, let's take the front off actually. I don't do an awful lot of these vintage things, but I do love vintage stuff. It's literally one of my favorite things is having old technology around to mess around with. I have a function generator that we can have a look at soon. I think it'd be really interesting to take a look at it actually. Let's see if we can slide that out without annoying the needle too much. There we go. So we don't have a manufacturing date on there, but we've got a number 8119. See if there's anything on the back. 51/C, no. Okay. Oh, look at those. Let's zoom in a little bit. So we've got some resistors here and some here. Oh, we've got some numbers. Let's have a little look at the schematic. So looking at schematic, we have 15, 16, 17 there. So let's see. So we actually have the component details here. So actually R4 is a 1.688 ohm resistor. So that's this sort of slightly coiled one. Let's zoom, not zoom, but focus back. So that's this one down here. So these are precision wound resistors. I can't see any labels on these ones, but those are also precision wound resistors. So I think they're probably likely to be some of the lower value ones like 0.1, 0.75 and 0.15. So probably these ones here, precision wound bits of wire essentially. Up here we've got 30 megohms, we've got 3 megohms and 15 megohms. We've got some little, what are those, germanium diodes down here. This is very magnetic, this thing. So that's a germanium diode. Is that correct? Let's have a little look. So miscellaneous, yeah, Z1 and Z2 germanium diode. Fascinating. I've never seen one of those before. Over here we've got a little transformer, so that must be the AC thing. So it's transforming the AC over here. So not using a bridge rectifier, but a transformer. That's fascinating. And up here we've got our inputs. And they were actually staked into this top section. Let's pull this forwards. You can see here where it was staked in, but I seem to have broken that, potentially. Yeah, looks like it. Or it was broken by somebody else, potentially, because there doesn't seem to be a stake in this other side here. I'm not sure I'm going to learn an awful lot more from this because I don't know what I'm looking at. But isn't it beautiful? So we've got our big old magnet here. Oh, that's not magnetic, but that certainly is. And basically it's resistors everywhere, which is what we expected from the schematic. So let's put it back together and we'll give it a little test. Right, so that's it back together, but now we need to replace these batteries. So I have a replacement for the SP2 battery. It is this, it is a D cell. So we're going to bung this in. And we need to replace this one. And so what I've got is this, which is a replacement for the BLR121. This cost me like £5, I think. And essentially, you can't really see it, can you? It's there we are. Essentially, this cell, which is 60 milliamp hours, so not a lot, is 15 volts, but it's a load of these kind of small cells stacked together. You can probably see that from the shape of this thing, but that's what this has been replaced with. So let's throw that in there. So these batteries are required for current measurement and not voltage measurement. So when you measure the voltage with an analog multimeter, it actually uses the voltage from the circuit. So it pulls current from the circuit. And because it's only got like it's like 50 microamp draw, I think. There we go, that looks okay. Now let's get the back on as well. And then we'll do some tests. So I don't have the original cables for this. So we're going to be using some of these little banana plugs to crocodile clips. I don't know what the resistance of the wire is, but we'll just make do. So negative to negative, positive to positive. We are currently in DC, so we need to select a range. So what should we test first? Should we test, actually let's test one of these batteries. We remember that was 13.3, wasn't it? It's a little bright, isn't it? Let's turn this down. There we go. So let's test that. I'm going to be 13.3. Actually, before we do that, we need to zero out this meter. So you can see over there, we've got our needle is not pointing to 0. So where's that screwdriver? Let's use that. So with parallax, you're not going to really be able to see it, the exact amount. But that, oh no, I've overcooked it. Back up, oh no. This is one of those Dave Jones tongue, oh for heaven's sake. Tiny. Oh. That's good enough for me. So that looks fine, right. So let's measure this battery now. So positive to positive, negative to negative. So let's put it in a range. It's 13 volts, so we're gonna have to go to the 25 range. Still a bit bright, isn't it? Let's just tone it down even more. Hopefully you'll be able to see those now. Now, pop this on. What have I done wrong? Our reset is stuck out. That's what it was. There we go. Now we can measure. Right, we're reading 10, oops. We're reading 10, 1, 2, 3, 10, 3.4. So 10, 3.4, 13.4 is what I mean. Sorry, it's me trying to add numbers in my head, not ideal. So yeah, 13.4. Let's read it with the other meter because it was recovering, wasn't it? So we're looking for around 13.4. Other way around. Try that again. 13.27. That's not far off, is it? So 13.4 versus that, so it's 0.2 of a volt. It's 5% accurate, I think. So that doesn't sound too bad to me. Where have those probes gone? Except our 0 is now down there. What's gone on? Let's adjust that again. Maybe because it was reset. It had its cutout on. Maybe we should try that again. No, we get exactly the same result, 13.4. That's cool. Let's try this other battery. We can change down to the 2.5 volt range. And again, why are we out? Seems to be getting stuck there. Not ideal. So I'm looking for 1.33 volts and I'm seeing 1.2.5. Now there may be some resistance in these cables that's altering our result, but let's read it with these ones. And I'm reading 1.31, so let's try this again. Yeah, 1.2 and a bit. So not ideal. Let's try this little battery because I know that one's good. So let's measure it here. 1.29732. That isn't changing. I'm not going to get down to those decimal points, but I would like to see 1.3 or at least 1.25. If the meter would stop doing that, would be wonderful. 1.3, so it's reading a good battery. So those other batteries, let's not trust results from those because they're wavering with current. So 1.3, that's good. Let's try it with my power supply and then we can, so the really good thing about these analog meters is you immediately see a difference in that meter swing, which is brilliant. So let's try it with the power supply and I can vary the voltage quite a lot and turn it on. So I'm expecting to see 2.95 here. So we're in 10 volt range. So it's the top range there. So we're getting 3, that's pretty good. Let's change our output voltage. So that's 3.95. Let's change it to 4 on the thing because that's, so we're now dealing with full volts. So that's 3. That's 1. This is looking good. That's 2. Do you want to come in a bit closer? So yeah, we've got 2 volts, 3 volts, 4 volts, 5 volts, 6 volts, 7 volts, 8 volts. It's bang on. 10 volts, not going to get all the way to the end there. 9 volts. Let's switch it up a range to 25 volts. We can actually go up to that on this thing. So we'll start down at 1 volt. Now where's our range on here? So we're looking, okay, so 1 volt is 2 of those spaces. That's cool. 2 volts. Yeah, that's pretty much bang on. 3 volts, bang on. 4 volts, bang on. 5 volts, right on that 5 there. Let's go up to 10. Yeah. 15. Brilliant. 20. And we'll jump into the 100 volt range and throw it up to 31 volts is the maximum I can go to. So we'll go down to 30. So yeah, this is reading pretty well across the range there. So I'm happy with that. Those batteries are sort of a bit of a waste of time measuring those because we don't know what state they're in. So let's do some resistance measurement now. So let's take our probes off. So that's what the batteries are. I've replaced them for, is that we can do some resistance measurement and trust the results. So move our selector around to ohms over here, and then we've got our ohm scale over here, which is a divide by 100 times 1 and times 100. So so times 100 would be for lower ranges, wouldn't it? So, and then divide by 100 would be for like your mega ohm scale. Is that right? Or no, actually the times 100's for the, yeah, times 100 is the value on here. So times 100 would be, oh, I don't know. Yeah, no, it's a kilo ohm scale. So times 100 on a kilo ohm scale takes you to mega ohms, doesn't it? I think. We'll figure it out. So let's choose one. I've got one here. We don't even need to tell it what, we can try and guess what value this is, can't we? So that is on the times 100 scale, and it is reading, let's do it on the 1:1 scale. So we're reading, what, 10.5K? Is that right? Let's check it on a real meter because I don't know how to read this thing, so it'd be silly of me just to make some assumptions on a real meter. That is horrible. I'm sorry, Selectest. What I meant was a meter that I know and use and is easy. So this is a 10K. So we're looking for 10K. So that'll help me set the range because I'm not quite sure what that means. So on a 1:1. Oh, do you know what I haven't done? I'm an idiot. Right, so with an analog meter, we need to zero out our cables. We do the same thing with modern meters as well, but I know that these are all right, so I don't have to worry, but we need to zero these cables out. So if I just do that, we can see that we're reading a resistance there. So let's dial it back. It doesn't like going all the way over there, does it? I don't know whether I've done something when I took the meter out, but we'll just trust that that's the end. So we've dialed them in. So let's put that resistor back on. So this is a 10K. What range should that be in? Ah, there we are. So we're reading just over 10. That's it's probably because this isn't ranged out right. Yeah, look. Not ranged out, I mean zeroed out correctly. So we've done it again now. I don't know why that needle is sticking, but it is very old, so I'll spare it. There we go, that's pretty much bang on 10 now, so I'm happy with that. Let's try the next one. And now we're going to try it without using the modern meter. Okay, so this one's not reading there, so let's turn it up. That's times 100, so times 100. So what would that mean? So we add on 2 zeros onto the end. So this would be something like a, what, 20 Ks, so it's a 1.1 meg ohm resistor. That's what that would mean, isn't it? 1.1 meg ohm. So let's test it with the modern meter. Oh, actually, we're reading, let's try and get it properly. So 1.4 meg ohms. So it actually is reading fairly out. You can see down here on these things we've got, it's not linear, the increase over here. So we've got 1 meg ohm, then 1.1, 1.2, 1.3, 1. Oh no, they're 2. So that's 1.25 is what it was reading. Let's see how far out that is. 1.25, so it's 200k out. That's a fair old whack, isn't it? Not sure about that. And then this one is my favorite resistor. This is a 470 ohm resistor. I use it with pretty much every LED going. So let's throw this one on, and hopefully it reads the lower ranges pretty well. So let's put it on 1 times. Yeah, that's fairly close. That's 500 ohms right there, and it's reading slightly below, and it looks to be about a third below. So about, yeah, it's bang on. Well, there we go. That's about all I'm going to cover with this meter. Thank you very much to Richard from Richard's Radios for providing me with the manual. Really useful and fun to read. And thank you to the person who gave this to me. I shan't name names. But it was Ashok, so he gave it to me. So thank you very much. It's been fun to play around with it, and I will be using it in the future. I think it's a nice bit of kit. I'm going to see if I can figure out why that needle is sticking, but I hadn't really played with it before, so it is my first time messing around with it, and I'm glad I've got some batteries now to be able to take full advantage of it. Anyway, if you guys know about these meters, if you've used them before, I would love to hear about your experiences with them. Obviously, if I've done something drastically wrong here, you can inform me. Even tell me off. Feel free. I know these things are close to a lot of people's hearts. Anyway, thank you very much, and I will speak to you all soon.